So remember we talked about where this ties into trigonometry is that on the xy plane, we're going to use a right triangle, but the points on that right triangle are going to fit within a circle. In fact, sine is called a circular function. So obviously we're going to talk about circles and stuff, and it does play into trigonometry eventually. So let's talk about this real quick. We're going to focus on, for this section, just like the previous section, remember that a circle, from the center of the circle, oh, that's not the best straight line. From the center of the circle to the edge, that's the radius. And sometimes we can measure part of that circle. So this angle theta here, because it goes to the center of the circle, right? This is the center of the circle. We call this the central angle. And the preference for central angles is to be in radians. Now they'll give it to you in degrees, and as you can see here, when it's in degrees, we just end up converting it anyways to radians. So we want that to be in radians. If they give it to you in degrees, you do the conversion. But today, what we're going to talk about is the area. So the area of a sector. So this little segment here. Oh, that's too thick. Let me. That's too. I'll try and do it. Yeah, we'll do it with yellow. I just got to do it lightly. So this, we can find the area of this section alone, and that is called a sector, a circular sector. So if I want to calculate the area of this section, like a slice of a pizza pie, that's what this formula is for. So this right here is called a sector. Okay. And then lastly, the length from here to here. Does anybody remember what that's called? That's called the arc length. Okay. Lastly, I should probably point out that when we say O, or actually theta sub r, that means that our measurement is in radians. Theta sub d means our measurement is in degrees. So when you go to do your homework, that's what you need to look for, okay? So anyways, there's two formulas to calculate that area. It's 1/2 times the radius times theta in radians. If they give it to you in degrees, it's the same formula, but you do this little conversion. You're converting the degrees into radians on the fly, okay? So let's look at an example and see how all this ties together. So for example number 1, I'm asked to find the arc length of a sector determined by the central angle 11 pi over 6. Now, because I see pi, what does that tell you about that measure? It's in radians, right? So now, when you do your homework, I do this thing where, because I memorize all these formulas and I just write the formulas down. But when you go to do your homework, you're going to get a question like this. You don't know the formula off the top of your head. So really what you're supposed to do is go back to your notes and go, oh yeah, if they give me the angle in radians, this is the formula that I'm going to use, right? So that's what you're supposed to do. And then you go, okay, well, to find the area, it's the area is equal to 1/2 times the radius squared times theta in radians. And we know that we're in radians. So I always draw the picture. I could just plug the numbers into, and they say the radius is 24 meters. Oh, wait, this says arc length, not area. So I reread the question. It says arc length. Do you guys remember the formula for arc length? Yeah, that's over r. So remember that theta in radians, same thing though, you would go back to yesterday's notes and you would find that the arc length over the rate, this is the relationship between them, right? And remember, this is our arc length here, and then our central angle theta is here. Well, we know that the central angle is 11 pi over 6 in radian. They want us to solve for the arc length, right? Remember, this is the arc length. Also, theta is what we call the central angle. Now, if I write it down, I want you guys to write it down. I know it's a central angle. You know it's a central angle. But if we write it down, it gets in your brain one more time, and that'll help you in December when you take the final exam. And so I'm sorry, what's that? Well, it's going to be comprehensive. So the arc length, though, is what they want us to find. Oh, I'm sorry, I plugged in the wrong thing. Yeah. So this should be 24 meters. Now, in order to get that out, because I need to move this away from the S, algebraically, it's dividing the S. So I do the inverse operation, which is 24 times, and I'm going to carry the unit with it. Now remember, whatever I do on one side of the equation, I have to do to the other. 24 divided by 24 is 1. Meters divided by meters is 1. So I get S is equal to all this stuff over here. Also remember that 24 divided by 6 reduces down to 4 over 1. So 4 times 11 is 44. We want to leave the pi in there, and that's it. Now, you could convert that, right? So if I pull up my fancy calculator, and there was a question yesterday about whether or not we can have a decimal answer or not. And I said, when we're doing radian measure, we always want to leave it in what we call the exact value, which is pi. But now we're talking about a length. So I think it's okay. Let me clear all this stuff out. I think it's okay in this scenario to plug this in our fancy calculator and get a decimal. So this is approximately